to 10th Board Booster Crash Series, which in fact is your last chance to prepare every topic from scratch. So hello everyone, my name is Ankita Singh, and in today's session we are going to take the chapter real numbers head on, and we are going to discuss all the concepts that it has, and we are going to practice all the different varieties of problems that have been asked in board exams since time immemorial. And I know that a lot of people struggle with word problems of HCF and LCM, so we are going to discuss tricks so that you can always tell in which word problems you have to find HCF, in which word problem you have to find LCM. Okay, now you'll also be getting all the class notes and you'll be getting chapter practice sheets, but for that you'll have to go to the link in the description box below, which will take you to PW's app, and there you have to enroll in PW's free batch and you'll get everything. Now I hope you know what PW is, right? PW is where quality meets affordability, where you get topmost lectures from India's best faculties, where you get the best results. Right? So yes guys, I hope that all of you people will be listening to these sessions with utmost concentration, and you'll be answering everything that you're doing in the comment box. Like, treat it like your rough page. So yes, let's start. And we are going to start with the first chapter of mathematics, that is real numbers. It's a very small chapter with very limited concepts. Basically, you just have two concepts here: fundamental theorem of algebra and irrational numbers. In fundamental theorem of algebra, you have questions based on the theorem itself and HCF and LCM, right? And you have word problems. Now, word problems is the part where a lot of people struggle. Then we have the proof that the given number is irrational. Like, this is something that is always asked in board exams, right? You cannot miss it, everyone. Okay, so mug it up, and I'll tell you how to mug it up. Don't worry. Okay, chalo. So with that, everyone, let us start. So we will start by revising some basic stuff that you have already studied in small grades, but I know that a lot of you people might have forgotten too. Okay, and please don't take these things very lightly, because believe me, a lot of MCQ from this chapter are very trivial. They come from these types of concepts. Okay, so please make sure that your concepts, these kinds of concepts, are solid. Okay, so let's start by discussing factor of a number. What is the factor of any number? Factor of any number is basically those numbers that divide the given number. For example, let us take 24, everyone. So what are the factors of 24? So to find that, we have learned in smaller grades that you just have to write 24 as product of two numbers. So 1 into 24 is there, then 2 into 12 is there, then 3 into 8 is there, then 4 into 6 is there, and after that repetition starts, 6 into 4 and so on, right? So 6 into 4 is actually 4 into 6 only. So you don't have to write it down. Now, all these are numbers, everyone. These 1, 24, 2, 12, 3, 8, 4, 6. These are all numbers that divide 24. They are all factors of 24. So the factors of 24 are what? 1, 2, 3, 4, 6, 24. Right? Okay. Now, you will notice that whenever you find the factors of any number, two numbers will always appear. Two numbers will always appear. What are those numbers, everyone? One number is 1. So 1 is a factor of every number. Like, 1 divides every number, right? So 1 will be always there, right? And another number would be the number itself. Not 24, okay? I have highlighted 24, but because 24's factor we are finding, right? If you find the factor of 6, then 6 will be its own factor. So basically, again I repeat, every number will have at least two factors, 1 and itself. Very simple, very important. Okay, now let's come to the multiple of a number, everyone. What is the multiple of a number? So multiple of any number is basically all the numbers appearing in its multiplication table, right? And you can also remember it like this, that multiple is of a number is the number that is exactly divisible by the given number. For example, let's take 24. So what would be the multiples of 24, everyone? So for that, all you need to do is write the multiplication table of 24. So 24 into 1, 24 into 2, 24 into 3, and so on and so forth, right? So 24, 48, 72, and so on. Right? So this will go on. So 24, 48, 72 and so on, they are all multiples of 24. They are all divisible by 24. Got it? Okay. Now, again, notice how 24 is a multiple of itself, right? So, every number is a multiple of itself. Every number divides itself, obviously. Now, how many multiples are there for a number? Infinite, because you can keep multiplying the number with different natural numbers, and you'll keep getting multiples of the number, right? Okay, now remember, multiple of a number, everyone, here I'll write multiple of a number is always greater than or equal to the number, greater than or equal to the number, or equal to the number, right, everyone? And what about factor, everyone? Factor of a number is always less than or equal to. Always less than or equal to the given number. Why have I written equal to? Because remember, every number is a factor of itself, every number is a multiple of itself. And that is why we write equal to also. Simple, basic, right? Okay, now let's move on to prime and composite numbers. Again, very basic stuff, everyone, but still you should revise it, because a lot of you people make very silly mistakes in lots of MCQ problems that are based on these concepts. Okay, what is a prime number, everyone? Prime numbers are those numbers that have exactly two factors. How many factors? Two factors. And what are those factors? 1 and the number itself, right? So can we write some prime numbers? You can write it in the comment box. I'll write it here. So let's start with 1. Is 1 a prime number, everyone? Because a lot of people do this silly mistake. Okay, they write 1 as prime number. Is 1 a prime number though? It's not. Why? Because 1 has only one factor. 1 is only divisible by itself, 1. And we have already written that prime numbers have exactly two factors. So 1 is neither prime nor composite. 1 is neither prime nor composite. Why have I written nor composite? We'll come to that when we are writing down the definition of composite numbers, right? So 1 is not a prime number, everyone. So the first prime number is 2. Then we have 3, then we have 5, then we have 7, we have 11, we have 13, and so on and so forth, right? Now notice that apart from 2, every prime number is odd, and that's very obvious. Why? Because apart from 2, every even number will have 2 as its factor, right? So every even number will have more than 2 factors, 1 in itself and 2 obviously, and others, right? Okay, so 2 is the only even prime number. Only even prime number. Rest, all prime numbers are odd. Rest all are odd. Okay, very simple stuff. I know a lot of you people already know it, but still I repeat, you make silly mistakes when it comes to questions. So please revise it. Now let's come to composite numbers, everyone. What are composite numbers? Please don't say that composite numbers are numbers that are not prime. Okay, because 1 is also not prime, but 1 is not composite, right? So the correct definition of composite number is basically all the numbers that have more than 2 factors. They have what? They have more than 2 factors, everyone, right? So let's write composite numbers. We already know that 2 is prime, 3 is prime. So the first composite number is 4. 4 is the first composite number. First composite number, or you could say 4 is the least composite number. Okay, smallest composite number. Then after that we have 6 and then 8 and so on and so forth. Okay, so remember 4 is the least composite number. Very simple. With that, let us now move on and do this problem here. It's a very interesting problem, and again, I assure you a lot of students are going to give the answer incorrectly. Okay, though it's very easy. Okay, so what's the problem? Total number of prime factors of a prime number. So first of all, we are being asked prime factors of prime number. Prime factors of prime number. Now we already know that prime numbers have 2 factors. 1 and the number itself. Number itself is prime. right? So any prime number will have 1 and the prime number itself as the factor. They are not asking all the factors, they are only asking the number of prime factors. Now I know that 1 is not a prime number, right? So how many prime factors does a prime number have? Only 1. Only 1. So what's the answer? The answer is 1. Did you give the answer as 2? No? Yes? Okay, so 1, option number A is the correct answer, and everyone that gave the answer correctly, pat yourself on the back, guys. Well done. Good job. Okay, so next question here. If A and B are two co-prime numbers, then A cube and B cube will be. Now, before doing this problem, obviously it is my job to revise prime numbers. Co-prime numbers, sorry. What are co-prime numbers, everyone? Co-prime numbers are basically numbers that have only one common factor. What is that one common factor? One common factor is 1 only. So basically all the numbers whose common factors is only 1, that means all the numbers which have only 1 as the common number dividing it are co-primes. Got it? Okay. Now, A and B are two co-prime numbers. They are asking about A cube and B cube. A cube and B cube. So, what do you think, everyone? I want the answer in the comment box. Do give it. Again, it's a question from board exam and directly based on factors, right? So, see everyone, if you already have co-prime numbers, that means they already have only one common factor, then obviously, if you take its cube, that is A into A into A, and you take the other number's cube, which is B into B into B, right? So, it's very obvious that these two numbers will only have 1 as their common factor. 1 as common factor. Yes or no? Right? So, what is the answer? The answer is that A cube and B cube will again be what? Co-primes. Right? So, the answer is option number A. They are both co-prime. Understood? Okay, and everyone that gave the correct answer, well done, guys. Good job. Now, let us come to HCF and LCM. Very important concepts. Again, something you have learned in smaller grades, but still a lot of students are actually confused what HCF and LCM actually means. Okay, and they just do what? They just mug up how to find HCF and LCM using prime factorization and think that that's the only thing that will be asked in problems. But that's not true, everyone. You should know what HCF and LCM actually mean, okay? Because a lot of problems, again, are based on the very simple concept of knowing these concepts. So what is HCF, everyone? HCF of two or more numbers is the largest positive integer that divides each of the integers. Okay, so basically, let's understand it using an example. So I'll be taking 24 and I'll be taking 32. Okay, now let's write down the factors of both of these. That means we are going to write down all the numbers that divide, 24 first and 32 there. Okay, so factors of 24 are 1, 2, 3, 4, 6, 32. Sorry, 8, 32. 12. That's it, no? 24, yeah. Okay, 1, 2, 3, 4, 6, 8, 12 and 24. Now, let's write down the factors of 32. That means all the numbers that divide 32, okay? So, we have 1, 2, 4, 8, 16, 32. Okay? Now, all we need to do is, first of all, find all the common factors. That means all the numbers that are dividing 24 and 32 both. Okay, so first of all, obviously, 1 is there. Okay, next, 2 is there. Next, 4 is there. Right, everyone? Next, 8 is there. And that's it. These are the only common factors. So, let me write down all the common factors here. Okay, so common factors. Common factors of both of these are what? They are 1, 2, 4, 8. Okay. Now, highest common factor. What we have to find? We have to find highest common factor, everyone. So, HCF, that is highest common factor. So, see, among all of these, what's the largest number? What's the highest number? 8, right? So, 8 here is the HCF of the given numbers. Understood? I have taught the very basic definition of HCF. This is HCF of both these numbers. Got it? Okay. Now, with that, let us move on to LCM. Okay. What do you mean by LCM of two given numbers? So, LCM of two given numbers is basically the smallest positive integer that is exactly divisible by each of the given numbers, or you could say lowest common multiple of both the number. Let's understand it using an example, okay? So let's say that you have to find the LCM of 24 and let's just suppose 16, okay? So how do you find it, everyone? First of all, you take the number 24 and write down its multiple, okay? So 24, 48, 72, 96 and so on and so forth, right? Now let's write down the multiple of 16, okay? So 16, 32, 48 and I'll stop here. Why did I stop here? Because I don't want to do any extra mehnat, because I know that lowest common multiple would be the common multiple which is the smallest, right? So you can see that 48 here is the first multiple that is common to both of these, and it would obviously be the smallest, right? So that means the LCM of 24 and 16 is what? It is 48. Understood? So this here is the very basic definition of LCM. Got it? We will be learning how to find HCF and LCM using prime factorization. Don't worry about that. But for now, focus on what LCM and HCF actually mean. Got it? Okay. Now, everyone, let us move on to some important points regarding HCF and LCM of any given numbers. First thing first, everyone, HCF. HCF is highest common factor, right? So, it has the word factor in it, right? And that means that HCF of any given numbers would divide each of the given numbers. It would do what? It would divide each of the given numbers. And that means that it would be less than or equal to all the given numbers. Right, because HCF is essentially factor of all the given numbers. So it would be less than or equal to all the given numbers. In fact, HCF of any given numbers would always be lesser than or equal to the smallest number among the lot. Smallest number among the lot. So let's just suppose that you're finding out the HCF of 68, 32, 128. Right? So whatever this HCF is, it would be less than or equal to the smallest number here, which is 32. It has to be less than or equal to the smallest number in the bunch. Remember that. Very important and very simple property. Got it? Okay. Now, HCF of co-prime numbers is 1. Now, co-prime numbers already have only one common factor. So that is what? That is their highest common factor. Right? So, yes. Now, let's come to LCM. Okay. So, LCM basically is lowest common multiple of the given numbers, right? And that means that LCM is always exactly divisible by each of the given numbers. So, let's just suppose you are finding out the LCM of 68, 48, 109, whatever. Right, so whatever this LCM comes out to be, this LCM will be divisible by 68 also, 48 also, 109 by definition only. And from here we can directly say that LCM of any given numbers would always be greater than or equal to all the numbers. Right? So whatever the LCM would be, it would be greater than equal to all the given numbers, 68, 48, 109. Now from here you can conclude that LCM of the given numbers would always be greater than or equal to the largest number among the lot, which is 109 here. Right or not? So remember, LCM of the given numbers is always greater than or equal to the largest number of the lot. Very simple, very basic, but you should know it. Got it? Okay, LCM would be greater than equal to the largest number among the lot. Okay. Now, LCM of two co-prime numbers. So, we have already discussed the HCF is one. What is the LCM? So, LCM of any two co-prime numbers would always be their product. So, that's very interesting, and we'll see why it is when we are discussing about finding LCM using prime factorization. Okay. So, yes, LCM of two co-prime numbers is always their product. Please remember it. Okay. Now, let's move on and discuss this very important thing. Very important and very interesting, because a lot of problems do come from these concepts. So first thing first, everyone, HCF of any given numbers is always a factor of the LCM of the same numbers. This is very important. Let's just suppose you have HCF of any two random numbers, 52 and 31. Okay, whatever it is, I don't know. Okay, now if you have LCM of the same numbers, 52 and 31. Okay, same numbers, everyone, same numbers. Then whatever this HCF comes out to be, let's suppose HCF comes out to be A and LCM comes out to be B, right? So A will be factor of B, factor of B. That means A will exactly divide B. A will exactly divide B. This is very important, and we'll discuss a problem directly based on this. Pakka. Okay. So remember, HCF is always, HCF always divides LCM for the same group of numbers. Okay. Now next thing, HCF into LCM would always be equal to product of the given numbers, and this is only true for two numbers. That means pair of numbers. If you have pair of numbers and you're finding their HCF, you're finding their LCM, then if you multiply HCF and LCM together, then it will always be equal to the product of the given numbers. A lot of problems are asked, specifically in MCQ type problems, from this concept. Okay, and it's a very easy concept. You can, mug it up right now. Okay, chalo. So with that, let's practice some problems. Okay. HCF of 96 and 404 is given as 4, and LCM of 96 and 404 is asked. Now, what is the use of giving HCF? Because we know how to find LCM, right? We know. We could have directly found LCM here. Why did they give HCF though? Because they did not want us to waste time. They wanted us to use a property here to find HCF. Sorry, LCM. What is that property? We just learned it, right? HCF into LCM is equals to product of numbers for pair of numbers, right? Now here HCF is given as 4. We do not know LCM. Product of numbers can easily be found by multiplying 96 and 404. Now please don't be stupid, everyone, and just start doing the multiplication here. No. Please be smart and always leave your multiplication for the very end, okay? So 96 into 404 divided by 4. This would be LCM. Now do the, the entire calculation. So we can see that we can cancel 4 and 404. So here we'll get 101. Now 96 into 101 is a very easy calculation. You can multiply 96 with 100 plus 1. Why? Because 101 is 100 plus 1. You can do this in your brain. 96, 100 plus 96. The final answer is 9696. See, why did I show you this type of calculation? Because in MCQ type problems, you can save a lot of time by being smart. Okay, a lot of people would have actually figured out LCM by using prime factorization. And there's nothing wrong with that. But it would take a lot of time. So if you can do it by using property, by doing easy calculation, please do it, right? So yes, I hope you understood it. What's the answer? The answer is option number D, 9696. And every one of you people that saw the question and instantly knew that you had to use this property, pat yourself on the back, guys. Well done. That is the point of this problem. Okay, now with that, let's move on to the next problem. Okay, LCM of two numbers is given to us as 2400. We are asked which of the following cannot be the HCF of the given numbers. So LCM of two numbers is given, and the question is simply asking you to find which number cannot be the HCF. What property are you gonna use? because we have, seen a property that would do, with that property we can do this problem like instantly. The property is HCF always divides LCM. Yes or no? Yes. So all we need to do is check which of these numbers is not dividing 2400. Okay, so first of all, let's check 300. 300 divides 2400. You can check, okay, if you want. This is the calculation. 2400 divided by 300. Will you get, your answer as a whole number? So the answer is yes. So that means 300 divides 2400. Very basic, everyone. Very basic. Right? So 300 can be the HCF of the two numbers. 400 again divides 2400. So again can be the HCF. 500 does not divide 2400. You can see, right? At the end, you will only have 24 by 5. Clearly 5, this here is not a natural number. So that means 500 here cannot be the HCF of the two given numbers because 500 is not dividing the given LCM. Okay, 600 also divides 2400. So yes. So this was a question you could do in your brain if you knew the property. If you did not know the property, then you would be like, like what to do, where to start, right? So yes, I hope you understood. With that, let's move on to the next problem. Okay, again, very easy, everyone. We have to find the ratio of HCF to LCM of what? Of least composite number. Yes, what is the least composite number? We have studied it in the session. It is 4, right? So we have to find the ratio of HCF to LCM of least composite number, which is 4, and least prime number. Least prime number is 2. Please don't write 1, everyone. Please don't do that. A lot of people do these kinds of silly mistake and lose marks. So we have to find the ratio of this. Khatam. That's it. Now, what is the highest common factor of 4 and 2, everyone? So, clearly the factors of 2 are 1, 2. Factors of 4 are 1, 2, 4. So, we can see that the highest common factor of 2 and 4 is 2. So, this is 2. What is the LCM of 4 and 2? So, again, I am teaching this very basic method of finding HCF and LCM. Okay. Because this is important, everyone. Very basic. So, the multiples of 2 are 2, 4, 6 and so on. The multiples of 4 are 4, 8, 16, 12, 16 and so on. Right? We can see that the smallest common multiple is 4. Yes? So, 4. 2 ratio 4, we can simplify it as 1 ratio 2. What's the answer, everyone? The answer is... yeah, option number A. This is the answer. 1 ratio 2. Simple, very easy, very basic, right? Okay, let's move on, everyone. And now let us discuss the most important theorem of this chapter. And you should remember the statement of this theorem. Okay, so mug it up. Let's see. Every composite number can be factorized as the product of primes, and this factorization is unique apart from the order in which the prime factors appear. So there are two parts of this statement. The first part is saying that every composite number can be prime factorized. That's all, right? So let's just take any composite number. We are going to take 720 and we are going to prime factorize it. Right, everyone? Okay. Wait, let me do this again. Yeah. Let's understand how to prime factorize in case you have forgotten. Okay. So, we have this composite number, everyone. We are going to prime factorize it. How do we prime factorize? So, we start by taking the number and we start by asking ourselves which primes divide this number. So, to keep it simple, you start by taking 2, okay? Does 2 divide 720? Yes, it does because you have 0 at the unit place. So, let's just divide this. What you'll get? 360. Right, everyone? Now, again, ask yourself, which prime number divides 360? Let's start by 2. Does 2 divide 360? Yes, it does. So, divide it, okay? What do you get? 180. Okay, again, Which prime number divides 180? Lot of prime numbers are there, but we'll start with the smallest prime number, which is 2. 2 does divide 180, so we'll divide it 90. Again, prime number 2 divides 90, we'll get 45. Now, 2 does not divide 45, right? So, we'll have to move to the next prime number that divides 45. So, does 3 divide 45? Yes, it does, right? So, let's write this down. 3 into 15 is 45. Now, again, 2 does not divide 15. 3 divides 15, right? So, we'll write here 3. Here, we'll write 5. And finally, 5 itself is a prime number, right? So, it will be only divisible by itself and 1. So, we'll write it as 5 into 1, 5. And once you get 1 here, it's done. Done deal. Khatam. So, it's as simple as that, right? Now, let's write down what we got. So, we can write down 720 as 720 is equals to 2 into 2 into 2 into 2 into 3 into 3 into 5. Now, we can also rewrite this entire thing as 2 raised to power 4 into 3 square into 5. Or we can write it as 5 into 3 square into 2 raised to power 4. Or we can write it as 3 square into 2 raised to power 4 into 5. Now, what have we done here? We have taken a composite number 720 and we have written it down as product of prime numbers, right? So, here 2, 3 and 5 are what? They are prime numbers, and 4 and 2, these are the powers here of prime numbers, right? So, that is what the first part of this statement is saying, that any composite number can be prime factorized, or it could be written as product of primes. Now, what does the second statement mean, everyone? That the order of the factorization is unique apart from the order in which the primes appear. So, first of all, factorization is unique, matlab that this is the only primes that are going to appear in 720's prime factorization. Like, you cannot have any other primes appearing. Okay, you cannot have the powers changing. The powers will be same, the primes will be fixed. Got it? The only thing you can do is change the order in which the product is being written. For example, all I did in the second statement, what did I do here? I just switch the order. I just wrote 5 first and then 3 square, then 2 raised to power 4. Here again, I switched the order, right? So, essentially, we cannot, get any other prime factorization of 720. This prime factorization is unique, right? Apart from the order in which primes appear. That means, all you can do is change the orders of the prime, right? But prime factorization is unique. You're going to get the same primes with the same exponent. Understood? So, please remember the prime factorization, the fundamental theorem of algebra in 2 parts. That would be easy for you. Okay? Now, let's move on and discuss problems directly based on fundamental theorem of arithmetic. Okay, the exponent of 5 in the prime factorization of 3750. Exponent matlab bacha power. Whenever exponent is asked, that means what you have to do? You have to prime factorize 3750. Right? And then you will have to see what is the power of the prime number 5. That power is the exponent of 5. Got it? So, for that, let's start the prime factorization of 3750. I want the answer in the chat box, guys. Let's see how fast you can give the answer in the comment box. Sorry, not chat box, comment box. Yes. 3750. Okay, so you can start by dividing it with any prime number that comes into your mind. So, for me, I'll start by dividing it by 5. So, what I'll get? 750. Again, I'll divide it by 5. 150. Again, I'll divide it by 5. 30. Again, I'll divide it by 5. Okay, now, I'm stopping here because, see, prime factorization is not done, everyone, because 6 still can be reduced. It's not prime, it can be reduced. But why did I stop here? Because I only had to tell the exponent of 5, right? And I can see that till here we got 5. Now 6 is not divisible by 5, right? So we are not going to get any more, 5s here. We are not going to get that. Got it? So you can say that whatever the prime factorization is of this number, it would be 5 raised to power 4 into something something. Okay, so you just had to tell the power of 5 and we can see that the power of 5 is 4. So this is the exponent. The answer is 4. Option number B. Everyone that gave the answer before me, pat yourself on the back, guys. Good job. Well done. Okay. Now, again, use smart work like this. Don't toil away and thinking, nahi, I'll do this entire thing. Only answer what, only do the problem, in the way that you get the answer. That's it. Okay. And these are MCQ type problems. Nobody is going to see the steps that you're doing. Okay. But still, for all of you people, that are like having a panic attack, ma'am, no, do this entire thing. I'll do it. Okay. Don't worry. 2 into 3 and finally 3 into 1. Cool. Done. So what is the prime factorization? The prime factorization would be 5 raised to power 4 into 2 into 3. Okay. Now, let's move on to the next problem. Okay. 4 is the answer. Okay. Now again, a very simple question. Okay. And directly based on prime factorization. So all we need to do is fill in the missing blocks here. Okay. So let us start by filling the box from the very bottom, because we can fill this bottom here. How? See, we'll just multiply 5 with 11. What do we get? 55. So 55 will come here. Now we just need to multiply 3 and 55 and this box will be filled. Okay, so what would you get? 165. Then again you'll multiply 165 with 2. What do you get? 330. And finally, 2 into 330, what do you get? 660. That's it, everyone. So what did we do? We started by multiplying the bottommost boxes and filling the boxes like this. Simple. That's the trick to do this problem. That's it, everyone. Okay. So yes, with that, let's move on and discuss this problem again, directly based on fundamental theorem of arithmetic. We have to find the unit digit of this thing, where n is what? N is a natural number. Okay, so n is a natural number. We have to find that this thing here ends with what? Okay, so first of all, let's take 5 raised to power n and 6 raised to power n individually. Okay, now everyone, what is the prime factorization of 5 raised to anything? So see, 5 raised to power 1 is 5. 5 raised to power 2 is 5 into 5. 5 raised to power 3 is 5 into 5 into 5. And so on and so forth. Right? Now, whenever you multiply any 5s together, like any number of 5s together, the unit digit will always be 5. You can see here, 25 unit digit is 5. 125 unit digit is 5. 5 raised to power 4, 625 unit digit is 5. So 5 raised to power n always ends with 5. Always ends with 5. That's very obvious. Now, let's talk about 6 raised to power n. Now, 6 raised to power 1, 6. 6 raised to power 2, 6 into 6, 36. 6 raised to power 3, 6 into 6 into 6, 216. Right? So, again you can see that no matter how many 6s you multiply together, it will always end with unit digit 6. Right? So, 6n always ends with 6. Okay. So 5 raised to power n will always have unit digit as 5. 6 raised to power n will always have unit digit 6, right? So no matter 5 raised to power n will be some number here with unit digit 5. 6 raised to power n will be some number here with unit digit 6. Now you're simply adding both of these, right? First of all, you are adding. So if you add both of these, we don't know about the other addition, but we know that the addition always starts from the right hand side. So we'll start by adding 5 and 6. 5 and 6 gives you 11. Now 1 will be written here while another 1 will go carry. So we had not bothered about rest of the addition. We are only bothered about adding 5 and 6. We got 1 here and another 1 got as carry, right? So that means that 2 raised to power n plus 5 raised to power n always ends with 1. It ends with what? It ends with 1, right? But they are asking us, this thing here ends with what? 2 multiplied with this ends with what? So very simple. Lastly, whatever number you get, you have to multiply by 2. Now again, the multiplication also starts from the right hand side. So 2 into 1 is 2, right? So this ends with 2. Ends with 2. That's it, everyone. What's the correct answer? Option number D. Everyone that gave the answer like within 10 seconds, kya baat hai? Pat yourself on the back, right? And all the people that that actually get confused like how this questions goes. So this is the way, okay? This is the way to do it, okay? So yes, I hope you understood this. With that, let's move on. Okay, now we have to show that this given number is not a prime number. Very, very frequently asked question in board exams. Okay, and very simple, guys, very simple, free ka marks. So remember, what is a prime number? Prime number is a number that has only two factors, 1 and itself. So to show that this is not a prime number, all I need to do is show that this number here will have more than 2 factors. That means all I need to show is that this number here will have a factor other than 1 and the number itself. Just one extra factor will suffice. So how do I do it? I write down the entire number. 11 into 19 into 23 plus 3 into 11. And I instantly see that this here is a mathematical expression with 2 terms here. And what I can do is, I can take 11 common from both the terms. Both the terms have 11 here, right? So I took 11 common, and in the first term, only 19 into 23 will remain. 19 into 23 will remain. While in the second term, after addition, only 3 will remain. Okay. Now, I have written down this given number as a product of 2 numbers. Right? I have written down this number as product of 2 numbers. And remember, when we were talking about how to find factors, what did we do? We wrote the number down as product of 2 numbers, and each of the numbers would be a factor. Right? So, since I have written down the number as product of these 2 numbers, so I can write that 11 and 19 into 23 plus 3 is a factor of the given number. Yes or no, everyone? Right? You don't have to do the calculation. That is not asked. Okay. Now, this number here clearly has more than 2 factors. It like obviously 1 and the number itself was a factor, but other than that, this also is a factor. These 2 are also factors. Right? Iski jagah R. Sorry, people. Grammatical mistakes. Okay, so we can say that the given number has more than 2 factors. The given number has more than 2 factors. More than 2 factors. Bas, that means that the given number is not prime. The given number is not prime. That is how you write, okay? We should learn how to write descriptive problems, right? So, yes, that's it. Simple, 2 marks, okay? Now, I hope you understood this. Let's move on to the next problem. Okay, acha. Before moving on to the problems, let's just discuss how to find HCF and LCM of given numbers using fundamental theorem of algebra. This again, very, very important. Very important. Okay. So, see, how do you find the HCF first? Let's see, okay. So, for any given group of numbers, what do you do first? You prime factorize the numbers. Each of the numbers you prime factorize. You know how to prime factorize, right? And after that, after prime factorizing the number, what you do is you take the product of the smallest powers of common factors. What does that mean? Let's understand. So, let's just suppose you have to find the HCF of 24 and 96. You have to find the HCF of what? 24 and 96. So, first of all, you are going to prime factorize both the numbers, right? So, yes, what is the prime factorization of 24? 2 raised to power 3 into 3, right? Okay. What is the prime factorization of 96, everyone? 2 raised to power 5 into 3. Right, everyone? Okay. Now, what you are going to do to find HCF? So to find the HCF of 24 and 96, you are first going to write down the primes that are common to both the factorization. So here you can see that 2 is coming in both the factorization, 3 also is coming in both the factorization, right? So just write down the primes that are appearing in both the factorization or all the factorization, right? And write a multiplication sign between them. Okay, now let's come to the power. So what you do to find HCF is you write the least power of the primes. For example, here the power of 2 is 3, here the power of 2 is 5. So you will write the least power, the smallest power, which is 3, right? So you'll write 3 here. Again, here both of the 3's have the same power. If they did not have the same power, you would choose the smallest power, right? So here both of them have the power 1, so you'll write power 1, right? So what's the answer, everyone? Answer is 24. That's it. 24 is the HCF of 24 and 96. Okay. Now, let's figure out how to find LCM of given numbers, right? So, let's figure out the LCM. Okay. Now, for LCM, again, I am going to take the numbers, the same numbers, 24 and 96. I'm going to take the same numbers. Okay, everyone. Now, for LCM, what you will do is, you will write all the primes that are appearing. Okay, you will not think about common primes. No. If the prime is appearing even in one factorization, you will write it down. Got it? So, let's just see here. So, what are the primes that are appearing? 2 and 3. And you will write multiplication sign between them. Got it? If let's just suppose here 5 was also appearing, but here it is not appearing. No worries, you would have written 5 down also. So you'll write all the primes irrespective if they are appearing in all the factorization or not. If they are even appearing in one factorization, you're gonna write it down. Okay? Okay, but this was only for understanding. Okay, now you are going to write the maximum power of each prime. So here what's the maximum power of 2? So you can see 5, right? So you will write 5 here. Again, what's the maximum power of 3, everyone? 1, right? You will write 1. That's it. So you can do the calculation. 96 is the answer. Understood, everyone? Okay, and we are going to discuss lots of problems on HCF and LCM. So even if you have a confusion, hold on. We are going to discuss lots of problems on HCF and LCM. They will be solved. All your confusion will be solved. Okay? Okay. Now, can you notice that here we took the HCF of 24 and 96 and got the HCF as 24 and the LCM was 96. So, whenever you have a pair of numbers and the HCF is coming out to be the smallest number and the LCM is coming out to be the largest number, that simply means that the larger number is a multiple of the smaller number, or basically the smaller number is a factor of larger number. That means 96 must appear in the multiplication table of 24. Got it? So basically what I wanted to say, again, if you're confused, if you have two numbers A and B, right, and A exactly divides B, like A exactly divides B, got it? Then in such cases, A would be HCF, B would be LCM. Nice, right? Okay, so whenever one number exactly divides the other number, smaller number is HCF, larger number is LCM. With that, let's move on, everyone, and do this problem. We have to find HCF and LCM of 404 and 96, and we have to verify also that HCF into LCM is equals to product of given numbers. Okay, so let's start by figuring out HCF and LCM. So for that, we would need the prime factorization of 404 and 96. So let us start from there. Okay, wait, let's do this. Okay. I hope you people are doing the prime factorization in your copy. Right? Come on, people. Math is all about practice. Okay? Please do not listen to this like a seminar ki haan baithe hain aur sun rahe hain. No, please don't do that, everyone. Please practice, please. Okay? So now here we have 404. So we can see that 404 here is divisible by prime number 2. So I'll divide it by prime number 2. I'll get 202. Again, I can divide it by 2. I'll get 101. Now 101, everyone, I don't think it's divisible by any number other than 101 because it's a prime number. 101 is a prime number. Please do not waste your time in figuring out whether it's a prime or not. There are certain types of questions or certain types of numbers that are repeated in board exams. Okay, so remember 101 prime. Got it? Okay, now let's move on to 96 everyone. Okay, so I can divide 96 by 2, right? So I'll get what? 48. Again I can divide it by 2, 24. Again I can divide it by 2. Then I'll get 12. Again I can divide it by 2, 6. Again 2, 3, and finally 3 into 1 is 3. Okay, so I have done the prime factorization, which was the main part. Okay, so I'll write down the prime factorization here. 404 is basically 2 raised to power 2 into 101. Understood? Okay. Now, 96 everyone is equals to what? 2 raised to power 5. 1, 2, 3, 4, 5, right? 2 raised to power 5 into 3. Okay, now let's start by figuring out HCF. Okay, so for HCF, what you will do, you will be taking only the common primes. So common prime here is only 2. Only 2 is the prime that is appearing in both the factorization. So only take common prime 2. Got it? Now you will take the least power of the primes. So here least power of 2 is clearly 2. So what's the HCF everyone? HCF is 4. Done. Now let's figure out the LCM also. So for LCM, what you will do? You will write down every prime that is appearing. So you have 2 here, you have 3 here, you have 101 here. All the primes that are appearing, you'll write it down irrespective of whether they are common to both the factorization. Okay, now you are going to write down the maximum power of each primes. So maximum power of 2 is 5 and 3 is 1. 101 is 1. Cool? Okay. Now you can do the calculation everyone. You'll get 9696. Okay. So yes, this is the LCM. And this problem here has appeared in board exams regularly, pretty important. And again, only basics required. Two numbers are in the ratio 2:3 and their LCM is given to be 180. We have to find the HCF of both the numbers. So first thing first everyone, let us write down the numbers. Let the numbers be 2x and 3x respectively. Yes, so whenever we are given questions where we have numbers in terms of ratio, so how do we take the numbers? Ratio quantity multiplied with variable, always, right? Okay. Now here everyone, this x could be anything. It could itself be a prime number or it could be a composite number which can further be prime factorized, you know, using fundamental theorem of arithmetic. Okay. So again, there are two scenarios. I'll write either x could be prime itself or x could be in the form of p1 raised to power n1, p2 raised to power n2 and so on and so forth. Okay, both of these are possible. Now, let's figure out the LCM of 2x, 3x. What would the LCM look like? Now, this is important. Here, the basics are important, okay? So, see everyone, whenever we are figuring out the LCM, what do? We write down all the primes that are appearing, right, in the factorization. So, we can see that here one prime is 2, another prime is 3. 2 and 3, right or not? Now, what are the other primes? We actually don't know. We just know that x could itself be a prime or it could be product of primes, right? So anyway, even if x is prime or even if it is written like this, we can write down the entire number like this x here. Yes or no? Or you could write p1 raised to power n1, p2 raised to power n2 and so on. Totally your choice. Okay, now you will multiply this. This is the LCM of both the numbers, prime factors which are here 2 and 3 and x, where x itself could be prime or it could be broken down as product of primes, whatever, okay. Now, this is equals to 6x, but we know that LCM is actually equals to 180 and from here we can say that, okay, x is equals to 30. Okay, but we have to find the HCF, right? So how would you find the HCF of both the numbers, everyone? Do you need to figure out both the numbers and then figure out the HCF? Yes? Or can you figure out HCF without finding out the numbers? Okay, again, basics. See everyone, what is HCF? When we are talking about 2x and 3x, the HCF would be the common primes raised to minimum power. यही होता है? Okay. Now, another definition of HCF is you just take out the highest common factor, right? So when we are talking about 2 into x and 3 into x, clearly 2 and 3 are not common. The only common thing is x. Yes, so x is the highest common factor of both the numbers. Yes or no? Just by basic understanding of HCF, I think you can understand this. X is the highest common factor of both the numbers. So that means whatever the value of x is, that is your HCF. You do not need to find the numbers here. And it is a very important problem, everyone, and it has a very simple explanation, but you should know what HCF and LCM fundamentally are. Got it? So yes, let's move on to the next problem. Okay. Not problem. Now we are going to discuss word problems where a lot of kids are actually very scared. So before moving on to word problems, we are going to talk about certain tricks that actually help in solving word problems. Okay? Let's start with HCF. HCF stands for highest common factor. So this is something a lot of people must have told you. I'll also tell you that if in a word problem, you see the words maximum or highest or largest, then you may have to find HCF. May is the important word. May have to find HCF. May have to find HCF. Why may, everyone? Because it's not always correct. There will be problems where you'll get the words maximum and highest and you still do not have to find HCF. We'll understand those problems also. Okay? So, may have to find HCF. Now, there are lots of problems where you do not get words like maximum or highest, but still have to find HCF. So, in those problems again, you might get words like groupings. So, in those problems, you will find that the problems are dealing with groupings, that you have to make groups. You have to do what? You have to make groups. Now, there are lots of synonyms of groups, okay? So, there use your common sense. Okay, so whenever you're talking about groups, the question is talking about making groups, then you will find HCF. Okay, now another very simple point here, and it's a very common thing that a lot of people miss. See, bacha, if you have a word problem, okay, and in the word problem, whatever you have to find, that quantity should be less than or equal to all the given numbers. Then obviously you have to find HCF, because HCF is always less than equal to all the given numbers, right? So remember, if you have to find quantity less than or equal to any given numbers, then you have to do what? You have to find HCF. This here is something that is common sense, but we know common sense is not very common. Okay? But please take note of this. This is the most important thing. Please, this will help you solve your word problems. Okay? Okay, now let's move on and discuss when to find LCM. Okay. Again, LCM stands for lowest common multiple. So that means if in any problem you have words like minimum, smallest, least, then you might find LCM. Again, might, may, matlab it's not fixed. Matlab there might be problems where you will see the word minimum, you will see the word least, but you don't have to find LCM. Instead, you would have to find HCF. So how would you know? We'll see that also. Okay, again, common sense. We'll use common sense. Let's see. So might find. Okay, this is not always true. Okay, another thing. There are lots of problems where you will not find the words like minimum, least or anything, but you will find words like together, simultaneous. Okay, so these words again mean that you will find LCM. Okay, these words are also important. If you find words like together, simultaneous, then also that means that maybe you have to find LCM. Now, these are all maybes. What is fixed though? What is fixed, everyone? This is fixed, that if in a question, whatever quantity you have to find, quantity to be found to be found has to be greater than or equal to all the numbers. All the numbers that are given. From that, the quantity that is to be found has to be greater than or equal to. Then obviously you have to find LCM, because LCM is always greater than or equal to all the given numbers whose LCM you are finding. Right? So again, this here is common sense, and this helps you find problems. Okay, this helps you find what you have to find basically. Okay, so with that, we are going to start by discussing word problems. Chalo ji, let's start everyone. The first problem, word problem is, two alarm clocks ring the alarms at regular intervals of 20 minutes and 25 minutes respectively. If they first beep together at 12 noon, at what time will they beep again together next time? I spotted a sweet word here which actually helps me identify whether I have to find LCM or HCF. Right? This together word we studied tells us that we have to find LCM. ठीक है? चलो जी. That means all you need to do is time when bells will beep together. Would be what, everyone? It would be LCM of the given numbers, that is 20, 25. Okay. Now please show the process of finding LCM. Okay. So 20 will be prime factorized as 2 square into 5. 25 will be factorized as 5 square. The LCM would look like this. In LCM, what do you do, everyone? You take all the factors, or sorry, all the primes that are occurring, and you write the largest power, right? So largest power here is 2, here also it is 2. So what do you get? 100. Now, this is not the final answer. Here 100 unit is minutes. Why? Because 20 and 25 have their units as minutes. So the LCM obviously will come out in minutes. This means that after 100 minutes, next bell will toll. Okay. So now they are saying that if the first bell tolls at 12 noon, like it rings at 12 noon, so the next bell will ring at what? 12 plus 100 minutes, right? So next bell will ring at 12 noon plus 100 minutes. Now everyone knows that 60 minutes means 1 hour, right? So 100 minutes can be broken as 60 plus 60 plus 40, right? So that means 1 p.m. plus additional 40 minutes, right? So you can directly say that 1:40 p.m. This is the final answer, everyone. 1:40 p.m. I think this was very simple, very basic. An army contingent of 612 members is to march behind an army band of 48 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Now here there are two words that are important, everyone: groups and maximum. Now both the words indicate that you have to find HCF. So no brainer, right? So that means maximum number of columns. Maximum number of columns, everyone, would be equals to what? It would be equals to HCF of 612, 48. That's it, right? Now to find HCF of 612, 48, first let's factorize 612. So we'll divide it by 2, we'll get 306. We'll divide it again by 2, we'll get 153. Then again we'll divide it by 3 this time. So we'll get 51. We'll divide again by 3, we'll get 17. And finally 17 is a prime number, so we are done, right? Okay. So that means you can write 612 as, you can write it as 612 is equals to 2 raised to power 2 into 3 into 17. Right, everyone? Now, let's prime factorize 48 directly because 48 is 16 into 3. So you can write it as 2 raised to power 4 into 3. Right? Now, what is the common, what are the common factors here, common primes basically? So, common primes are basically 2 and 3. So, 2 into 3 everyone. Now, what is the smallest power here for 2? It is 2 and for 3 it is 1. So, finally, you get the answer as 12. Right? So, that means that the maximum number of columns here would be 12. Simple, basic, okay. Now everyone, let us move on to this problem here. This is an interesting problem. I want all of you people to please pay attention. Okay, and here we'll be using common sense. Got it? In a teacher's workshop, the number of teachers teaching French, Hindi and English are given to be 48, 80 and 144 respectively. Find the minimum number of rooms required if in each room the same number of teachers are seated and all of them are of the same subject. Now, a lot of people hone on to the word minimum, think minimum matlab LCM, find out the LCM and leave it at that and get 0 marks. Why? Because they did not use common sense. See, let's go back to the very basics and think, what do we have to find? We have to find number of rooms in which teachers will be sitting. In groups, groups word is not there, but that is what the question is asking you. You have to find the minimum number of rooms. Rooms basically groupings. Rooms matlab groupings. You have to find groupings, right, of these teachers. So now you should think that whatever the number of rooms would be, it would not be greater than all these numbers. Is that possible? Would you have number of rooms greater than 144? No, right? Number of rooms has to be less than all the given numbers, or maybe equal to one of them. So, if we have to find a quantity that is either less than or equal to the given numbers, then how can I find LCM? I have to find HCF. That's what my common sense says. Right? And another thing, you have to find rooms. Rooms matlab groups. Right? Groups matlab HCF. So, you have to find HCF here. That is the main part. Got it? Okay. Now, a lot of people now ask, ma'am, why the minimum word though? Why minimum word? Because HCF though a maximum word, right? A maximum implies HCF. But here we have minimum. So see. When will you get minimum number of rooms? Minimum number of rooms. Minimum number of rooms is required, will get minimum number of rooms when maximum number of teachers are sitting. Right? If we have maximum number of teachers in one class or one room, then we'll have minimum number of rooms. So, minimum number of rooms required, maximum groupings of teachers. Maximum groupings of teachers. If we can make number of, if the, in a group, maximum number of teachers are there, then obviously we'll require less rooms. That is the key here. So, maximum grouping of teachers. Now, here you will find what? You will find HCF, right? So, let's find number of teachers in a group. Number of teachers in a group. Or we should use the word maximum here. Maximum number of teachers in a group would be what? It would be the HCF of 48, 80, 144. So, let's quickly figure out HCF and let's answer in the comment section everyone. Come on. Okay. So, 48. We just saw, right, that 48 is what? 48 is 16 into 3, right? So, 2 raised to power 4 into 3. 80 is what? 80 again is 16 into 5. So, 2 raised to power 4 into 5. And 144 is 16 into 9. So, 2 raised to power 4 into 3 square. So, you can be fast in your calculation provided you practice a lot. Otherwise, you can go and do the entire prime factorization process. Okay, chalo. So, now HCF would be what? So, you can see 2 is the only prime that is appearing in all the factorization. So, in HCF, you'll only have 2 with the least power and the least power is 4. So, 16 everyone. That's it. So, 16. So, that means maximum number of teachers in a group would be 16. Got it? Now, what would be the number of rooms required? Because this is still not done, okay? So now let's move on and talk about number of rooms. Number of rooms. So number of rooms would be what? First of all, let's see. We have 48 French teachers, right? So these 48 French teachers would be, will make groups of 16 teachers each. So 48 divided by 16 will give us 3 groups. That means there are 3 rooms that are required by French teachers, right? Plus, there are 80 Hindi teachers. So if we are making groups of 16 each, then number of groups would be what? 80 divided by 16, right? And finally, we have 144 English teachers. So 144 divided by 16. Now this will give you 17 groupings. That means 17 rooms, everyone. Understood? Right? So this entire problem was based on common sense. That's it. So use that, everyone. Do not always rely on tricks, because tricks might lead you in trouble. Okay? Chalo. With that, let us move on, and we have come to the last section of this chapter, where we are going to discuss irrational numbers. But first of all, what is a rational number? A rational number is a number in the form p by q, where p and q are what? They are integers, and the denominator q cannot be 0. You have all studied it, so let's move on. Now, let's talk about irrational numbers. What are they? Dekho, irrational numbers are numbers that are not rational. That means irrational numbers are numbers that cannot be written down as the ratio of 2 integers. What are those numbers? So we have root 2, root 3, root 7, 5 minus 3 root 2, so on and so forth. Pi is also, pi here, pi is also irrational, right? So the world of irrational number is quite large, and in irrational number also you have different types of irrational numbers, which you'll be learning in higher grades. So you don't have to go in depth about that. You should just know certain examples of irrational numbers. Okay? Also, you should know that in decimal form, irrational numbers will have non-terminating, non-repeating decimal form. What? Non-terminating, non-repeating. I'll write it here. Non-repeating, non-terminating, non-terminating. Both of these should be true. Decimal form. Okay? For example, if I write 0.01, 001, 0001, 1, 2, 3, and so on. This pattern continues. Now here you can see that there is no block of number that is getting repeated. Also after decimal, this is going on forever. So non-terminating. So this here is an example again of an irrational number. Okay, got it? So yes, these are our irrational numbers. Now, let's discuss this theorem. We are not going to discuss the proof of this theorem. We just need to know this theorem because it will be used in the most important proof of this chapter. Okay, so if p is a prime number and p divides a square, where a is any integer, okay? So if p divides a square, everyone, then p divides a. So if any prime number divides the square of any positive integer, then that prime number will also divide that number. Understood? This is very simple, and please remember it because it is highly used in the most important proof, again I repeat, of this entire chapter. Okay? Chalo. Now, before moving on to the proof, we are just going to discuss about irrational and rational numbers together. So what happens if we operate irrational and rational number together? So dekho bacha, whenever you add irrational number plus rational number, you will always get an irrational number. Always. So if I ask you what is root 5 plus 5, your answer would be, it's like, you can't do anything about it. 5 plus root 5 is an irrational number. That's it. It's what? It's an irrational number. Got it? Similarly, irrational number minus rational number, again irrational number. Again irrational number. If I ask you what is 2 minus root 3, again it's irrational. It's what? It's irrational. Okay? Now, irrational number multiplied with rational number, again irrational number, by again. For example, if I do root 2 into root 3. It will come out to be root 6, everyone, which in itself again is what? It's an irrational number. Got it? Okay. And finally, irrational number divided by rational number, or rational number divided by irrational number, matlab you can actually interchange it. Then again it will be irrational. And again, here I am specifically saying rational number cannot be 0. Because if irrational number is divided by 0, then again division by 0 is not defined, right? So that's why I have excluded 0 from here. Got it? So yes, irrational divided by rational, where I'm not including 0, then it would always give you an irrational number as the result. Okay? Chaliye. Now, what happens when you have two irrational numbers and you are adding and subtracting and multiplying and dividing them? What happens then? Let's understand. Okay, so dekho bacha, remember, if you have two irrational numbers, then it's not necessary that their addition or their multiplication or their subtraction or their division will give you an irrational number. It might not give you an irrational number. Got it? For example, we can see very basic examples. If I have root 5 and I have minus root 5, what does this give us? If I simply add root 5 and minus root 5, what does this give? Both of these are irrational number, but my answer is rational. My answer is what? My answer is rational. Similarly, if I have, let's take root 5 only, root 5 into root 5. The answer is 5. Again, I am multiplying two irrational numbers and I am getting a rational answer. Again, root 5 divided by root 5, 1. So, these are just few examples that show us that if you add, subtract, multiply or divide, you might not always get an irrational number. You might get an irrational number, you might get a rational number. Both of the results are possible, right? So, if somebody in, if in a basically exam, question is asked whether irrational plus minus irrational is what, then it could be both rational, it could be irrational. You can't determine. Got it? Same goes for irrational into or division irrational. Again, it could be both irrational or rational. Okay? Now, what about rational? So, this is something you have discussed in smaller classes also. I hope you remember that rational numbers, they follow closure property. That means if you add rational number, you get a rational number. If you subtract rational numbers, you'll get a rational number. If you multiply rational numbers, you'll get a rational number. And if you divide rational numbers, again, you'll get a rational number apart from 0, because you will have to take out 0 in division, right? Because division by 0 is not defined. So remember, operating rational numbers together would give you a rational number, but not irrational numbers. Got it? This is important, very basic. You can remember these examples. Okay? Here's a question for all of you people. The number 5 minus 3 root 5 plus root 5 is what? Is it an integer? Is it a rational number, an irrational number, or a whole number? Okay, everyone, we have, what we can do here first of all is we can simplify minus 3 root 5 plus root 5, right? How do you simplify minus 3 root 5 plus root 5? So, think about it. We can take a root 5 common because it is coming out in both of these. Basically, what I am trying to say is minus 3 root 5 matlab minus 3 into root 5. Got it? Now, use simple arithmetic that you have been utilizing till now and see that you can take out root 5, right? If you take out root 5, you will get minus 3 and here only 1 will remain because root 5 is already out. So, here you will have root 5 minus 3 plus 1 minus 2. What do you get? Minus 2 into root 5, which you can write as minus 2 root 5. Root wala part is always written after the integer wala part. Got it? So, minus 2 root 5. Okay, but you also have 5 here, right? So, this entire thing becomes what? This entire thing becomes 5 minus 2 root 5. You can see that 5 is a rational number. 2 root 5 is an irrational number. You cannot further evaluate them. The answer obviously is an irrational number. When you operate a rational and irrational number, you will always get a rational number, right? So, yes, the answer is option number C. Everyone that gave the correct answer, pat yourself on the back, guys. Good job, well done. Okay. So, yes, an irrational number is your answer. Okay. Now, remember, the chapter name is what? Real numbers, right? So, in the world of real numbers, you have rational number and you have irrational number. Got it? Now, within rational number, you have the world of integers. You have the world of fractions, of whole numbers, of natural numbers. Okay, and irrational number is like, you still divide irrational numbers into different kinds of numbers. And again, I repeat, you will be learning that in higher grades. Okay, chalo ji. Now, let's come to the most important question of this entire chapter. These types of problems would obviously come. You should know the steps, everyone. So listen closely. Okay, you have to prove that the given number here is an irrational number. Now, the proof always starts with a contradiction. Proof always starts with a contradiction. So always step one. Step one is what? Step one is basically assuming that the given number is actually rational. Let root 2 be a rational number. Rational number. This is step number one. You are going to assume the opposite. That whatever we have to prove, that's not true. It's in fact rational. Cool. Now, if it is a rational number, then that means you can write it in the form of ratio of two integers where the denominator is not equals to 0. Right? So, let root 2 be equals to a by b, where a and b are co-prime integers. They are what? They are co-prime integers. Co-prime integers. And obviously, b is not equals to 0. Obviously. So, I have just written down the definition of rational number. But why did I write a and b as co-prime? So, we have all studied that if you have a fraction or if you have basically a rational number, you can always simplify it, right? You can actually divide the numerator and denominator by their common factor till no common factor other than 1 remains, right? So, yes, we have assumed that what we did here was we wrote root 2 in the simplest form. As a rational number, we wrote it in the simplest form, where a and b, they do not have any common factor other than 1, right? Now, here, bacha, remember, this co-prime word is the most important thing in this entire proof. Got it? So, yes, co-prime word is very important. Do write it down. Now, step one was assuming the number is rational and then doing what? Then writing it down in rational form. Now, what is step number 2? Step number 2 starts by taking what we already took, root 2 is equals to a by b, and from here we can say what? We can say that, okay, this basically means that a is equals to root 2b. We can write it like this, a is equals to root 2b. Now, what I am going to do, I am going to square both the sides. Squaring both sides. Okay. So, what does squaring both sides give us? Here we'll have a square and on the other side we'll have 2b square. Root 2 square is what? Root 2 square is 2. So, 2b square. Okay. Acha. Now, a square is equals to 2b square. So, can I not say that, okay, this means that 2 divides a square? Can I say that, everyone? Did you understand this? See, a square is equals to 2 into b square. That simply means, no, that 2 must divide a square. Right? If you can write a number as product of two numbers, then both the numbers must be a factor of the given number. We have studied that. 2 divides a square. Now, here comes the theorem. 2 is a prime number and we studied that if prime number p divides the square of any number, then it will also divide the number itself. So, if 2 divides a square, 2 divides a. 2 divides a. You will write down the theorem, right? If prime p divides a square, where a is positive integer, then p divides a. Okay? Please write down the theorem that you are using. That's why I wrote it down for you. Got it? You also have to do that. So now 2 divides a and that tells us that a can be written as 2k. Yes or no? If 2 divides a, then obviously I can write a as 2 into something. So 2 into k, okay, where k is a integer. non-zero integer basically. Got it? Now, please name it as 1 here. Now, step 3 starts. Which step starts? Step 3 starts. Okay. Step 3, everyone. Now, in step 3, what I am going to do, I'll also know, wait a minute. I'll also name this. Let this be 1, everyone, and this be 2. Okay, this is better. Okay. Now, step 3 starts by putting 2 in 1. Putting 2 in 1. Okay. Now, what do we get if I put 2 in 1? So, basically, in place of a, I'm going to write 2k, right? So, here we have a square. So, that means 2k square is equals to 2b square. From here, if you simplify this, if you simply simplify this, what do you get? You will get k square is equals to 2b square. Sorry, I'll rewrite this again. 2k square is equals to b square. This is what you'll get. You can just open it up. You'll get 4k square is equals to 2b square. So, b square is equals to 2k square. Now, b square can be written as 2 into something. And that tells us that 2 must divide b square. 2 is a factor of b square, right? So, let's write that down, everyone. 2 is a factor of b square. So, that tells us that 2 is a factor, or 2 divides, you can write divides also, totally your choice, of b. Again, by the same theorem, everyone, if a prime number p divides a square, then it must divide a, right? So, write down the theorem. Now everyone, we have seen step 4 here. We have seen that 2 is a factor. 2 is a factor of b and a both, right or not? 2 is a factor of b also and a also, both of them. But did we not assume that a and b are co-prime? We did. Remember, I told you that co-prime is the most important thing here, because we are going to ultimately prove that a and b are not co-prime. Okay, so that's why here we have proved that 2 is a factor of both a and b. So, you will write, but a and b are co-prime. Now, that simply means that there is a contradiction. There is what? There is a contradiction. And contradiction means your assumption is wrong. Assumption is wrong. Assumption is wrong. Assumption was what? That root 2 is rational. So, that means its opposite must be true. So, root 2 is an irrational number. Very simple, right? So, let's go back, everyone. See, step number 1 was what? It was assuming that root 2 is rational and then writing down the definition of rational number. That means root 2 can be written as a by b, where a and b are both integers and b is not equals to 0. Now, the important thing was, rather than just taking a and b as integers, we said that a and b are actually co-prime. So, basically, we are writing root 2 in its simplest form. And co-prime is important. You cannot miss that, because you are ultimately going to prove that a and b are not co-prime. Now, step 2 starts with root 2 as a by b. From there, you took, the square on both the side, and you saw that a square is equals to 2b square. Now, if a square can be written as 2 into something, that means 2 divides a square. That means 2 divides a. And if 2 divides a, that's the important part here. 2 divides a. Okay. Now, if 2 divides a, then a can be written as 2 into something. So, 2k. So, we took that a is equals to 2k and we again put it here. Here. We put it here. Right? Here. Like this. Okay. So, what do we get? We got that b square is equals to 2 into k square. So, that means again b square is 2 into something. So, 2 divides b square. So, 2 divides b. So, here again 2 divides b, or 2 is a factor of b. So, 2 is a factor of a, 2 is a factor of b. That means a and b are not co-prime. That means our assumption was wrong. That means root 2 is actually irrational. Baat khatam, done. Okay, that's it. So, you can get root 2, root 3, root 5, root 7, and all the proofs are exactly same. Exactly. Got it? Okay. Now, with that, let's move on and discuss these types of problems. Now, this time we have to prove that 5 minus 2 root 3 is an irrational number, and it is given to us that root 3 is an irrational number. Now, this second part is very helpful. If it was not given that root 3 is an irrational number, then the first thing you would have to do was you would have to prove that root 3 is irrational and then proceed. But I'm very sure you will not get such long problems. If you have such kind of, expression here which you have to prove irrational, then always the root wala part would be given irrational. It would always be given that it's irrational. Okay. Now, let's see how we can do it. This is again very easy. That's why it's a 2-marker problem, everyone. Okay. So, first of all, what we'll do is, again, contradiction. These types of problems always start with contradiction. Let 5 minus 2 root 3 be rational. Okay, let it be rational. Okay, if 5 minus 2 root 3 is rational, then we can write it down as 5 minus 2 root 3 is equals to a by b. Okay, where a and b are integers and b is not equals to 0. That's it. Here co-prime word is not important, okay? That's not the issue here. So you can just write a and b are integers and b is not equals to 0. That would be more than enough, okay? So we have written down the definition of a rational number. Now, what we are going to do is, we are going to basically figure out the value of root 3 from here. We are going to figure out the value of root 3. So we'll take everything on the other side except root 3. Got it? Chalo. And why we are going to do that? You will see. Don't worry about that. So, minus 2 root 3 is equals to a by b minus 5. Right? I took positive 5 on the other hand side. Now, I'll take minus 2 on the other side. So, we'll get a by b minus 5 over minus 2. Let's just simplify it. Okay, let's just simplify it. So, I'll get root 3 is equals to 5b minus a. 5b minus a over 2b. I have simplified it. That's all I did. A by b minus 5. So, a minus 5b and b is in denominator. It will go on in the denominator, and I actually chose to remove the negative sign from the denominator. Okay? So, root 3 is equals to 5b minus a over 2b. Now, remember guys, a and b both are what? They are integers. Right? Okay? So, if a and b are both integers, then 5b is also an integer. 5b minus a will also be an integer, and 2b obviously is an integer. So, both of these numerators and denominators are integers. Yes or no? Yes or no? We have studied in smaller grades that integers follow closure property. Right? So, 5 into b is an integer. 5b minus a would also be an integer. 2 into b also would be an integer. Right? Okay. So, they are integers. Also, 2b is not equals to 0. Why is it not equals to 0? Because b is not equals to 0. So, if b is not equals to 0, 2b will also not be equals to 0. So, that means what I have done here, everyone, I have shown basically that root 3 is basically, is the ratio of two integers, right? So, I can write it like this. Root 3 is the ratio of two integers, and the bottom integer is not equals to 0. Right? You can write that down. That means that root 3 is rational. Obviously, that's the definition of rational number, no? Any number that can be written down as a ratio of two integers where the bottom integer is not equals to 0, then that number is obviously a rational number. Root 3 is rational. But they have already given to us that root 3 is an irrational number. Matlab, contradiction. Right? So, yes, this can't be true. There is something that we assumed wrong. What was our assumption? That 5 minus 2 root 3 is rational. So, from here we can say 5 minus 2 root 3 is irrational. See, so easy, right? So whenever you do get these types of problems, there always utilize the root wala part. Figure out the root wala part in terms of ratio of integers, and there you'll get the contradiction, because root wala part will not be a rational number. Okay, they will always give root 3, root 5, root 7, something like that. Got it? So yes, these are the two types of proofs of irrational numbers that are most commonly asked in your exams. So if you do not study anything in the entire chapter, then also please study both the proofs and study fundamental theorem of arithmetic. That's it. Matlab, all these topics are so easy, they will give you free ka marks. Okay, so do not skip. So yes, with that, here's a homework for all of you people. I would love the answer for homework in the chat box. Oh, sorry, comment box. Okay, so yes, this again is a question that has been asked in your board exams. So yes, that's it for today, everyone. I'll see you again in the next one-shot session, and remember to get your notes, to get your practice problems by clicking on the link in the description box below and enrolling in PW's free batch.